between what we have today means that security becomes a question of scale. And this scale is a real big problem. It's a great boon and benefit for agility and flexibility, but it sucks when it comes to security. So I'm going to give you you can read the slide later. It basically says, look, these are just illustrations. Don't get hung up. I'm not here to pick on one vendor or another. These are kind of, think of the big picture, not the little illustrations. So if you think, when we talk about those three layers, infrastructure, metastructure, and infostructure, let's look at the fact that, for some reason we have expectations that physical failures just don't occur in the cloud. We get all shocked. The funny thing is, Rackspace, Amazon, Google, Microsoft, huge power failures have all caused numerous data center outages. Shouldn't be that way, right? That's what we're told, but in case they do. CI Host in Chicago was a victim of robbery. Guys busted through the door with an axe, busted through a concrete wall with a sledgehammer 4 times. Stole switches in their servers like 4 different times. Core IP networks, although this isn't really a physical issue, it's actually kind of like a Fourth Amendment issue. Was interesting in as much as, guys show up to search, FBI shows up to serve a search warrant, says, great, we want this content and this information. We don't know where it is. It's all virtualized. So they took the entire data center. Right? What does that mean to a Google or an Amazon when these sorts of things start to flex their model? So the physicality of where things are located gets to be kind of important. When we think of infrastructure also, I talked about re-centralization of data. These mega data centers really change traffic patterns. They change the entire consumption model and interchange and peering models. And you add mobility and starting to move workloads around based on the provider's requirements or yours, gets really, really interesting. And if you have a failure in a large mega data center with 50,000 cores, for example, that support 100,000 customers, unless I'm doing real-time replication of content and data that coexist with service levels that match 5 nines uptime, you're going to tell me I'm going to migrate an entire data center in real time from one continent to another without outage? That's very kind of interesting. And what that means over shared fiber, because this is a map of the kind of the inner tubes, quite literally, suboceanic cables, and we've seen already what happens when you have an earthquake in China, like most of the Middle East goes bye-bye, or when you have accidental, quote-unquote, 7 anchors being dragged across the bottom of the ocean that happen to cut 7 different fiber points. Sure, it's an accident. You see most of the Middle East go bye-bye. So the kind of interesting thing here is when you think about the shared fiber and things go boom, besides the fact that the beauty of cloud, as I say, is that the notion of infinite scale comes with the potential of infinite fail, right? So while some companies own their own dark fiber, the majority of the kind of, I don't want to say second tier to make it seem more diminutive, but cloud providers that aren't at the scale of Google or Amazon depend upon shared fiber just like most of the rest of the internet does. So even if they're medium size, migrating 20,000 nodes or data centers, shifting workloads across shared fiber means that, ultimately as these things start to pile up, the notion of what this means if your bandwidth goes away or gets plugged is very interesting. We've seen kind of going up a layer, the abuse by the insiders or attackers. Actually, it's not talked about a lot, but core infrastructure exploits are kind of interesting. The guys at ERNW owned an entire metro carrier Ethernet provider. They were essentially able to, once they got onto the network, subvert and transparently redirect traffic without the knowledge of either party over an MPLS network, and did so because they were able to use old school tools that allowed them to essentially shift labels around by detecting and running a basic cracking application on the shared secret that was used, which happened to be the name of the router vendor. Really embarrassing, right? Then you get things like, okay, what about the free email archival capabilities that we get for free as U.S. citizens by the NSA? We've heard that we have people tapping and intercepting data and voice phone calls. The expectation of privacy because you're going over MPLS networks and they're quote unquote encrypted doesn't mean a whole heck of a lot. And then the notion we heard yesterday that I've been talking about for a while, that virtualization and cloud really forced a return to these big flat layer 2 networks. So we actually see the return and adaptation of old school tools like Yersinia and Ettercap, and you'll be amazed at what you can do with these basic old school attacks. We've seen stuff that Joanna Rakowska has done in abusing monoculture levels with hypervisors. which is scary to say the least. I was really annoyed about how it was originally positioned, and then I kind of cleared my head a little bit, because the implications of Zen in cloud providers is much more profound today than, for example, what it means for Zen in an enterprise, because they just don't have that penetration. So at first, the way it was being talked about, I kind of didn't get the impact here. But when you start to think about what this means in open source environments, what it means in a vendor that has 90% of the market and virtualization layers, both in the enterprise and now expanding to cloud, is quite frightening when you can think about bypassing things at the chipset layer. So the introduction of monocultures is pretty interesting. When we start thinking about shared images, where you can basically go to one of these portals and say, I'll have one of those, and launch it in 10 minutes. The interesting point here is whether you go to VMware, whether you go to Zen, whether you go to VMware or Amazon, you're downloading packages that you quite honestly don't know what's in. Are they already Trojaned? Are they already rootkitted? What do they do? The guys at SensePost at Black Hat last year did a great thing where they talked about putting a really sexy named AMI up on Amazon, and people just downloading it and launching them. Right? Phone home, they could have done anything to those images. And most people who are just taking for granted that they're secure and not applying reasonable common sense things, especially when you think that mass market consumer versions of cloud are targeted at the SMB, they're not going to armor these things. So they're going to deploy more and more insecure operating system application stacks. We see things like that aren't supposed to happen, that are theoretically improbable, not impossible. But Aaron Tromer and the guys did this really interesting thing where they used brute forcing to be able to actually detect where the next iteration of an Amazon AMI would be placed. So they could actually brute force placement of an image next to a corresponding target. Now it got handled and discussed. Like, unfortunately, they talked about side channel attacks as being the kind of concern, meaning, even though the attacks weren't possible, that was the hand waving that the vendor started to use to say this is irrelevant. What they were saying was, no, look, we're white hat researchers. Imagine what black hats will be able to do if they can essentially predict where workloads are being placed. This was interesting too. Guy Rosen, there's a thing in World War II where the Allies were trying to predict how many panzers the Germans had, so they came up with all these statistical models, and then some guy said, I think we should count the serial numbers, and that basically told them how many tanks they had, to the accuracy of like plus or minus 5. It was pretty interesting. So Guy Rosen did something where he was able to use resource IDs to abstract very similar usage. You could actually then, if you were a black hat, imagine probing to see if somebody's using auto-scaling to predict how many things they will actually scale to know how resilient it is, and or force a failover to another region. So you can start thinking about, again, iterative notions of infrastructure that people weren't thinking about. And then this guy over here, I renamed his attack, if you want to call it that. Should I call it that? His research. I'm sorry, his research. I call it V Motion Poison Potion. Where ultimately the interesting notion here is if you apply this to, let's say, one of those owned MPLS networks, the thing in the middle here, you have the capability to intercept data. In this environment with this virtualization vendor, when you do something called vMotion, you can actually have a running image over here, and then you can chunk it over this network, and actually at a point in time in which it's ready to operate, you basically deactivate this one and activate this one. And this nasty character over here was able to inject, because that network is unencrypted, was able to inject code and have code that is different running over here than it was over here. Very interesting implications if you start thinking about mobility and what that means. John, I don't know if you pointed out at Intel that time of that talk that there's indeed a checkbox in the GUI that says please encrypt this network. You can check it all you like, but at least at that point it did nothing. It was a future placeholder. Has that been fixed? Okay, so don't check that button, or check it and be pleasantly surprised when it doesn't work. I think I'm actually over time, but so anyway, going up the stack, you've seen cloud burst escapes. Oh, look, 2 of those 3 people are here. We've seen DNS attacks. We've seen BGP attacks. Prefix hijacking, man in the middle. These handshake kind of polite clients wouldn't do this type approaches to security in the internet with core protocols that really enable all of this functionality. issues with trust models of the consumption at the consumption layer that interact with services like BGP, like DNS, like SSL. These things are fundamental today as we move the trust to like the fact that the client itself is reasonably secure, puts us at extreme jeopardy. And then we have developers who would just want to kind of go out of their IDE, their integrated development environment, push deploy, and have it move to the cloud. And that's not unreasonable. To them, cloud's just a platform, right? They don't want to think about infrastructure. But then we have this notion of DevOps that's starting to come. It's really starting to intrigue me, where developers are starting to write policy and code within the applications themselves and use scripting to essentially automate everything, including security. Or at least that's what they think they're doing. I'm very interested in understanding how this notion of developers and